In section 5.2.7, the question states that a probability experiment is conducted in which the sample space of the experiment is the following. We have the numbers that go from 10 all the way to 21. Event F is 14, 15, 16, 17, 18, and event G is 18, 19, 20, and 21. And assume that each outcome is equally likely. We list the outcomes in F or G. We want to find the probability of event F or event G by counting the number of outcomes in F or G. And by determining that, then we would use the general addition rule. So all the outcomes that are in either event F or G means that you have to include them all since it's an or statement. So you're going to take all the elements in F, which is 14, 15, 16, and 17, and all the elements in G, which is 18, 19, and 21, and therefore that would be the set of F or G. So we want to be able to find the probability of F or G by counting the number of outcomes in F or G. So to find the number of outcomes in F or G, we can see that we have a total of 1, 2, 3, 4, 5, 6, 7, 8. So therefore the number of outcomes in F or G is 8. And the number of outcomes that are in the sample space are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore the probability of selecting a number in F or G is taking the number that's in that F or G divided by the number in the sample space. So 8 divided by 12 then becomes 0.667. Now we want to be able to know how to determine the probability of F or G using the general addition rule. G is equal to the probability of event F plus the probability of event G minus the probability of F and G. Now, the probability of event F, meaning that how many elements do we have in F? So we have 1, 2, 3, 4, 5, and we're going to divide it by the total number that's in the sample space, which is 12. So 5 divided by 12 gives us 0.417. In the probability of G, well, we have 1, 2, 3, 4 numbers in G. So 4 divided by 12 gives us 0.33. Then we're going to have to subtract the probability of F and G. And the definition of F and G means that it's called intersection, meaning what values does F and G have in common? So if we take a look at both of F and G, we notice that there's an 18 that's an element in F, and then we also have an 18 that's an element in G. So what that means is they have one value that they have in common. So to find the number of values that F and G have in common is the value of 1. And we're going to divide it by the number in the total sample space, which is 12. Therefore, the probability of F and G is equal to 0.083. So now if we plug this back into the formula, and if we take 0.417 plus 0.333 minus 0.083, if we do the order of operations, it's going to give us the same result as what we found in the first part of this question. So in this scenario, we can do either or for the general addition rule. But it's important to understand this definition.